In this lecture, you will learn about the photoresistor. A photoresistor is a simple resistor that is variable, and its actual resistance depends on how much light is hitting its surface. You can see a photoresistor here. This is the top side. This is where the light comes in and changes the resistance that we can measure from its two pins. As I said in the previous lecture, photoresistor is essentially a variable resistor, just like a potentiometer is. But as you can see, a potentiometer has got 3 pins, whereas a photoresistor has got just 2 pins, which means that we will need to connect it to the Arduino in a slightly different way than we did with the potentiometer. And that's what you will learn about in this lecture. In terms of software, the software side of what we're about to do is identical to what we did in the previous lecture. So essentially we'll be using the same sketch, but with a different circuit. If you want to learn more details about the photoresistor, then again, you can refer to Arduino Step-by-Step Getting Started, where I've got a dedicated section on how to measure light and color, and a couple of lectures in this section are dedicated to the photoresistor. More about this in a moment. So first of all, how do we wire a photoresistor to the Arduino? So here is the wiring schematic. This is how you would connect a photoresistor, the variable resistor, to the Arduino. And we do that with the help of a fixed resistor. Essentially, you have the 2 resistors, variable and fixed, with a common pin, and we take a signal from this joint between the 2 resistors to one of the Arduino's analog input pins, in this case, analog pin 0. The other side of the photoresistor goes to power, 5 volts, and the other side of the fixed resistor goes to ground. Now you might be wondering, what is the value of the fixed resistor? How many ohms should the fixed resistor be? And there is a way to calculate that. I go into the details in Arduino Step-by-Step Getting Started. So if you're curious, you can go in here and learn how to calculate an accurate fixed resistor for the photoresistor. But as a ballpark figure, if your photoresistor is rated as a nominal value of 10 kilo ohms, then you match that with a fixed resistor, and you match it therefore with a 10 kilo ohm resistor. And that's what I'll be doing here as well. So let's go ahead and do the assembly. Take the potentiometer away. Here is my 10 kilo ohm resistor. And as I said earlier, this is a photoresistor with a nominal value of 10 kilo ohms. So I'm going to assemble it so that the 3 pin of the photoresistor is powered up by the Arduino at 5 volts, like this. So I've got, straighten this up a little. So I've got 5 volts coming in to the photoresistor on 1 pin. Then the second pin will have a joint with the fixed 10 kilo ohm resistor. The sampling pin, which is a 0, this is white jumper wire, will take a sample from the joint between the photoresistor and the fixed resistor. And finally, ground is plugged into the 3 pin of the fixed resistor. And that's the circuit. Now from this point onwards, it looks identical to what the potentiometer looked like, where the middle pin of the potentiometer is sampled by the white wire. All right, I'm going to plug it in to my computer. Now the Arduino is running the same sketch as in the previous lecture, where it's taking a sample of the voltage on analog pin 0 and converts that into a number from 0 to 1023. So let's have a look at these numbers coming through. You can see them coming through down here. I'm just going to clear the serial monitor, and there's the numbers. And if I do something like provide some shade to the photoresistor, you can see how the value of the output drops If I allow some more light to come through, value increases. I'm going to use the flashlight on my phone to shine some light directly onto the photoresistor. You can see the value goes up, and this will be easier to see in the plotter. So here's a plotter. Just going to turn on interpolation, produces a nicer graph. So darkness or relative darkness, there's a lot of ambient light here, but you can see how the resistance changes and therefore the value that the Arduino is measuring on analog pin 0. Okay, so at this point we have the photoresistor connected to the Arduino and it is producing output. It's just that this output is not very useful. What we're going to do in the next lecture is to make some modifications to the sketch and potentially to the circuit itself so that the values that are produced from this setup are more useful. So instead of just getting an arbitrary value between 0 and 1023 that relates to the ambient illuminance, we'll be getting a value that is more standardized and has more meaning when it comes to the question of how much ambient light is there. And that is called lux. So there's several different ways to measure illuminance, but a lux is a common one. So in the next lecture, I'll show you how you can modify the sketch and potentially the circuit as well, so that the number that comes out is in the lux scale instead of the analog to digital converter scale.